this class we are going to discuss about zeroth law of thermodynamics. So before going to discuss this zeroth law of thermodynamics, let's recall last what we have discussed. We have discussed about adiabatic wall, right? Adiabatic wall, then diathermic wall we discussed, right? What is meant by adiabatic wall? Adiabatic means where there is no flow of energy or no flow of heat. Okay, but in case of diathermic wall it will allows heat. Okay, it will allows. Okay, that is the difference between adiabatic and isothermic, I mean adiabatic and diathermic wall, right? Fine. So now we'll see it. Zeroth law of thermodynamics. Zeroth law of thermodynamics. What it is zeroth law? Already there is a first law, second law is there. Why it will be called as zeroth law? They can start from first, second, third, no? Then why it is called as zero? Because before finding this, they already found those two laws. Okay, that's the reason they kept a name as zeroth law and as a fundamental law, right? Okay, so what is the zeroth law of thermodynamics? If two systems are in thermal equilibrium with a third system separately, then they must be in thermal equilibrium with each other. Okay, let's see that. I have a body A and body B. Two bodies are there in contact, but here there is a wall will be called as adiabatic wall. So what is meant by adiabatic wall? Adiabatic wall is also called as insulating wall. Okay, so that no current will be flows through it. Okay, now in between these two, same adiabatic wall only there, adiabatic wall A B. Now here I placed one more system, one more object or one more body. Okay, so that what will be, here there is a wall, here there is a wall, this wall I consider as an diathermic wall. Okay, what diathermic wall will do? It will conducts. It is an conducting wall. Okay, A B, this is the adiabatic wall, and between A and B adiabatic wall is there, between A and C or B and C there is a diathermic wall. What adiabatic wall do? Adiabatic wall will stops the flow of energy. What diathermic wall will do? Diathermic wall will do flow of energy. It will exchange the energies. Okay, so here there is no exchange of energy has been taken, but here the energy will comes here and energy will goes here. If it has high temperature, it will flows from high temperature to low temperature. Okay, right, that means until how long it will passes? Until these three temperatures remains same. Okay, right, it will flows after some time, until some time it will flows. Now what happened is this part is being removed. Which part? This part, C part is alone removed. That means now I am going to place same A B, but the wall is replaced. I am just removed this alone. Okay, between A and B, and instead of this adiabatic wall I am keeping one diathermic wall. Okay, so what will be happen? I kept that diathermic wall. Now what should happen? Energy should be transferred. But is it transfers? After removing this temperature and this temperature is being constant, so that no flow of energy takes place. There will be no flow of energy as the system is in this one. What is that? Thermal equilibrium. So the system is in thermal equilibrium. Okay, that's why there is no transfer of energy takes place. Okay, so the property of thermal equilibrium is used in the measure of temperature. Okay, so what it will use? property of thermal equilibrium is used in measure of temperature. Okay, clear? Right. So now another concept is Joules law of heating. Joules law. Joules law and as well as um, and heat, that is called as mechanical equivalent of heat. Here for example, there is one object here and here is another object, both are have more irregularities. Now I am pushing this one on the surface, then what will be happen here? Friction is there, no? So what will be happen to this? Because of the friction there will be heat will be generated. Instead of that, take your two hands and rub together, then what will be happen? Friction. Because of the friction heat will be generated. So what you are doing here? You are doing a work. You are doing a work against the friction. You are doing work against the friction. Okay, so that what will be developed? Heat will be developed. So because of the work, what is developed there? Heat energy. Okay, because of the work, what will be developed? Heat energy. So work done is directly proportional to the heat. So that will be written as work done equal to J into heat, where J is called as Joules constant, where J is called as Joules constant or Joules constant of proportionality. Okay, right. Or this also called as mechanical equivalent of heat. Mechanical equivalent of heat. Mechanical equivalent of heat. If, for example, in this case, if H equal to 1, then work done is nothing but J is nothing but equivalent of heat. Okay, so from this what can we define? So Joules mechanical equivalent of heat is defined as the amount of work required to be done to produce a quantity of heat is unit 1. Okay, so the amount of work done required to be done to produce a unit quantity of heat, that means heat will be 1. Okay, if that much work will be happen, then we can say that mechanical equivalent of heat. Okay, clear? Mechanical equivalent of heat, when if the heat will be 1, if that much amount of work is done, then we can say heat is uh, work done is equal to mechanical equivalent of heat. Okay, so here it have one significance. Here it is having one significance. What is that significance? One significance is there. What is that significance? Whenever you're doing this work, what will be happen? Heat may be gained or heat may be loose. So that means heat may gain or lose. Heat may gain or lose by a system. Heat may gain or lose by a system. Like we have taken no A, B, C like this. So total system. So from one, for example, if we'll take same this, one body to another body, energy is transfer takes place. So in this, one is gaining energy, other is losing energy. So the gain or loss of a system in the process, in this process, in some work is process, in that, so the gain of loss heat can be taken as, this will be taken as equivalent. Okay, Joules law of equivalent. Okay, are you getting? So heat may gain or lose by a system in the process. During the process, at that time, the heat loss or gain by a system taken to be the equivalent amount of heat. Equivalent amount of heat is joules. Okay, so equivalent amount of heat. So this is only called as heat energy or thermal energy. This we are going to use in terms of in the problems. Work done is equal to joule amount of heat. Okay, here generally heat will be measured in terms of calories. Work will be used in terms of joules. Okay, so 1 calorie equal to how many joules? 4.2 joules. Already in last class we discussed 1 joule equal to how many ergs? 10 power 7 ergs. Okay, got it? Right. Now if work is measured in terms of ergs, then the value of J will be equal to 4.2 into 10 power 7 erg calorie inverse. Okay, erg calorie inverse or erg per calorie. Okay, got it? So if heat is measured in terms of calories, 1 calorie is 4.2 joules and 1 joule equal to 10 power 7 ergs. Even in terms of joule also, for this is for both. If work is measured in terms of ergs, okay, then then joule 4.2 into 10 power 7 erg calorie inverse. Okay, oh here 1 calorie equal to 4. J calorie inverse, mention it. J means joule, joule means 10 power 7, so joule will be replaced with 10 power 7 ergs. Okay, so 1 calorie equal to 4.2 joule calorie inverse or 4.2 into 10 power 7 erg calorie inverse. Okay, clear? Right. Here J is there, no? So this J is not, it's not a physical quantity. J is not a physical quantity, it's just a conversation factor. Important. Okay. J is not physical quantity and it is a conversation factor. Okay. Clear? Right. Now, okay, we'll see the problem now. So hailstones fall from a certain height. If they melt completely on reaching the ground, find the height from which they fall. So let's consider there are many hailstones. Okay, when it will be fun, when it will be fall, when it is the time of rain, basically it will form at that time. Okay, so it's a hailstones means it's a kind of ice cubes. Okay, so on reaching the ground, these are coming to the ground. On reaching the ground, it's going to completely melted. That means because of some heat. So I'm going to write heat as heat energy Q. Q equal to, it's going to melted this all ice cubes of each having mass m, and when it's going to be melted from there to here, ml, latent heat will be this. Already you knows this about in case of thermal expansion of matter. So Q equal to ml, and it is falling from where? Some height, that is potential energy mgh. Okay, so when it is falling from there, these two will be equated. This is according to this formula. What is it? Work done equal to mechanical equivalent of heat, right? So work done is mgh. Okay, and it is what? J is equivalent of heat. So that is equivalent of heat is nothing but ml. Heat energy lost or gained by the body is taken as mechanical equivalent of heat. Mechanical equivalent of heat. Okay. So that is nothing but Q, that is ml. So mm gets cancelled. Gh equal to L. So H equal to L by G. So what is this latent heat? It is 80 calorie per gram. Okay, L will be given as, L will be, it will be fixed value, you can remember it, 80 calorie per gram by G value is, let's take it is 10. Okay, clear? Then from this, H equal to 80 into, it is, this 10 is in meter per second square, right? So we have to convert it. So 80 into 1 calorie means how many joules? 4.2 joules into, it's in divided by grams. calorie per gram. Per gram means by 10 into gram. Gram should be converted into kgs. 1 gram equal to how many kgs? 10 power 10 power 3 or minus 3? Minus 3 kgs. Okay, so you don't need to mention about units. So 10 power minus 3, 10 power minus 3 will goes up. So 80 into 4.2 into 10 power 3 by 10. 0 0 gets cancelled. Then after this, what you will get? It is 33.6, 33.6 into 10 power 3. Okay, 10 power 3 meters. That's nothing but 33.6 kilometers. This is the height which is going to be taken. So while reaching from there to here, it's going to completely melted. The height we don't know, so that height is 33.6 kilometers. If it will falls, then it is going to be completely melted. Okay, right. We'll see the other one. A body of weighing 42 kg eats bananas whose energy is for 980 calories. If this energy is used to go to height h, find the value of h. Okay, so here they have given mass. Mass is how much? 42 kg. And whose bananas, whose energy also given. What is that energy? 980 calories. So 980 into 4.2 joules. 1 calorie equal to 4.2 joules. Okay. If this energy is used to go to height h, what is that height h? Okay. So based on this, what same formula? Work done, work done equal to mechanical equivalent of heat. Okay. So here mechanical equivalent of heat. What heat it is? The energy. This is the one. Okay. That is 980 into 4.2 equal to work done mgh. So 980 into 4.2 equal to mass is 42, g is 10, and h we don't know. Okay, 4.2 ones are 4.2 tens are 0 0 gets cancelled, then it is 9.8 and 0.8 meters. Okay, where it is? So it is h equal to 98 by 10. So it is 9.8 meters. Okay.